Hello and welcome to the second class in the Art and Code course series. Today we are going to be focusing our efforts on recursion and motion. So we're going to look deep into some mathematical concepts that I feel are super important for creating striking pieces of generative art. And we're going to look at that through the lens of some basic motion techniques for P5. What we will be centering that art discussion around is going to be some art composition techniques and the language of art composition and art criticism. I'll remind you that in our first course, we looked at color and the structure of a P5JS sketch, as well as the structure of this course. We're going to take a brief review tour through some color and structure work, and then we're going to focus deep into this recursion and motion stuff. So here we are, we're going to do our review. We're going to look at art composition techniques. My goal with this is to give you some language around which to look at your own art and also to look at other people's art. We'll get more into why I think that language, why rhetoric is really important later on in the presentation. The next thing we're going to talk about is recursion. If you have experience with computer science and recursion from a theoretical level, I want you to stick around and keep your brain on for that portion of this lecture. And that's because we're going to be looking at recursion in an art-specific way. I think the concepts that I've learned in computer science classes and in code really stick with me in a different way when I see them played out visually and when I'm actually able to create visuals utilizing that recursion. So stick around, don't disappear on me. The last thing we're going to do is, of course, the same thing that we do every class. We'll spend about half of this class doing a live code along demo with me, looking into these techniques. So how are we going to use recursion? How are we going to reflect on our art composition? And how are we going to bring some of the things that we learned about color in our last course into the motion space? Talking about color, you'll remember that we looked at these 6 color schemes. These are traditionally the 6 color schemes that are taught to art and design students. And you can, of course, take this to its logical extreme, but every color you add is a color that you need to manage and a color that needs to be balanced with the other colors in your work. These are just a great rule of thumb for finding color schemes. You should have left that course with the understanding of what each of these color schemes is and how to code them inside of a P5JS environment, utilizing some sort of randomness for generative art. If for some reason you feel like you left that lecture and you need help, please come visit me at office hours. I will catch you up, or go back and look at just those sections that you feel like you need brushing up on. That's the amazing thing about being able to record these lectures, is you can also revisit them for content as much as you want, and you definitely don't have to watch the whole thing, which is magical. The internet is magical. So ultimately, I would say a review of these color palettes is the more complex they get, the harder they are to balance, but typically the more visually interesting they are. It also changes over time, so you'll see different trends towards different color schemes in each design and art industry, sort of in waves. So recently there was a big fashion trend for monochromatic outfits. Just something to look out for. Use your color lens in your life and you will get better at utilizing color in your work. So, a review briefly of the structure of a P5JS sketch. This is super important because we're going to start utilizing a different part of this structure today, which is why I'm drawing your attention to it again. The part of our sketch that we spent a lot of time in the first class is the setup function, or written function setup. The setup function runs once when you first start your sketch, and then after that it stops. There are ways to complete a similar task using the draw function, which we will get to later on in this course. But if you were just looking to create a piece of still generative art, it would be absolutely doable to do such things in the setup function only. This second function, the draw function, is the one that we're going to be utilizing heavily today. This function runs at a fixed frame rate. We'll explore how we can utilize that frame rate and some basic math and looping to do animation inside of our sketch today. A brief reminder of the important parts of any sketch in P5. Make sure you are always creating your canvas with that command inside of your setup function. It should be the first thing you do in setup every single time you create a sketch. You can declare variables above setup. You can even declare functions above setup if you like to see the world burn. I have obviously my own way of structuring my code, but inside of your setup function, always the first thing you need to be doing is creating your canvas. The canvas is pixels wide by pixels tall, and today we are actually going to utilize these built-in variables inside of P5.js, width and height. These are the outputs of the create canvas command, so you can utilize them later on in your code. You'll see what I mean in a bit. Next, we talked about the background, how to initialize the background color of your canvas. You'll remember that this color is RGB, but typically on the P5 web editor, when it just initializes a sketch for you, it initializes it in grayscale, which you will remember is represented by a single number in the RGB space in JavaScript. Last, we talked about a couple of basic shapes. There are two kinds of shapes, the kind that are generated with one point and a value like a diameter or a side. There are the other kind of shapes where you actually point out each vertex of the shape. So a triangle would be a great example of this. You're actually saying, I want my x1, y1 value to be here, x2, y2, x3, y3. So this is just a review of the concepts I want to make sure you're getting out of this course every single time you sit down with me. Today, we are going to focus deeply on composition, of course, because there's a huge portion of this lecture devoted to composition. This is where you're going to get most of that. However, we're going to utilize that language throughout this lecture and the next two. So we're not leaving it behind. It'll get wrapped into everything we do, just the same as color theory will be today. We are also going to start looking at math for art. So recursion is a mathematical technique first and foremost. We're going to talk about that later. We will also start to introduce trigonometry into this lecture, but we will focus very heavily on that in our third lecture, which is all about natural motion. We're also going to explore Perlin noise next week. So this week we're just focusing in on recursion, which I think is a huge chunk to bite off, and we'll get a little bit into utilizing trigonometry for animation. So let's talk about the principles of art composition and why they're important, give you some language for talking about art. There are two things that play into this conceptual space. Just like a house is made up of fixtures and ornaments and windows, a piece of art is made up of visual elements. And a piece of architecture might be described as spacious or continuous or cozy. Those are sort of more in the space of principles of composition. So principles of composition are ways of discussing how a piece puts itself forward and how it's structured, whereas visual elements are the things that are being placed onto your art surface, being put into your art, being patterned around, because all art really is generating patterns for people, and the ways that those things wrap into an actual composition. So first, of course, we're going to talk about the visual elements, those pieces, the doors and windows of a work of art. The first thing that gets drawn out inside of this space is line work. So your lines are a super important part of your composition. Are they scratchy? Are they thick? Are they thin? Do they bleed? What does a line look like in your piece of art? I think this is especially important inside of the digital space. In a physical space, a lot of what you're working with is your tools. So if I choose to pick up a marker, that marker has a bunch of inborn tools. In P5.js, you are styling each and every single line that you draw. So be thinking really critically about why you're selecting that specific style for the line that you use. Why are they short? Why are they long? Why are they continuous? Why are they broken? Drawing your attention to lines is a part of your artwork. The next thing that you can utilize to create an engaging piece of art would be the shapes. So shapes can obviously be what we literally talked about in our last course, just shapes. But in a broader fine art sense, shapes can also be the line of a human body or the way a piece of clothing drapes. It's more the way a form is structured. and what about that contour is interesting. Tone and color are sometimes separated, and I want you to think about them as separate, but they have a lot to do with each other. They stand on each other's ground. So tone is typically used to refer to something being warm or cold or high contrast or high saturation, or the opposite of that, of course. I think of this a lot in terms of Photoshop tools. So if you have any familiarity with editing photographs or even on your phone, the way that you edit pictures, how are you toning your photos to change the mood or to change the artistic composition? Of course, this is different than color. So I chose to wear a red shirt and a peachy headband today. That would be a color choice in that I am going very heavily on like the monochrome side of the spectrum. All of these colors are analogous to one another, but tone-wise, they're quite different. I'm creating some sense of contrast with this peachy, pastel-y, like low saturation light color in contrast with this very vibrant red shirt. So I hope that I hope that tracks for you. I hope that understands for you. I hope that tracks for you the difference between tone and color and how they work in balance with one another. The next visual element of art is patterns. So patterns are a great way to create a sense of connection between different parts of your work or a sense of discordance. So we'll talk about discordance in this next slide, where we actually go into the principles of composition. Patterns are things that repeat. I think that's pretty obvious. It's very much a part of our language, the word pattern, and I think that brings forth something really obvious for you. Think about all of the different patterns that you experience every day and the way that things are patterned that you might not actually realize. So natural patterns are a big part of this. It can repeat, but maybe not regularly, or it could be completely symmetrical and mathematical and copy paste. So just noticing patterns, I think, is a great way to get to know them. Texture is an incredibly important part of all artwork, but again, very similar to a line, is something that you really have to be thoughtful about when you're undertaking digital art. So how are you pulling texture into your work? Are you choosing to go without texture? Are you choosing to add texture? There are a lot of free textures available online, and I will show you today how to pull those things off of free photo sharing websites. I have a handful that I personally like, but we won't consider that to be any sort of like endorsement of those products. I'm just going to show you what my process looks like for pulling patterns and textures. Last on this slide, we're going to talk about form. Form is also sometimes referred to figure ground inside of a Gestalt psychology view. We're not going to get into that type of Gestalt because I think it's encapsulated well here. We will visit Gestalt and motion in our next course. However, form is the shape of a body or a subject on a canvas. There can be many subjects or one subject, but how is it shaped? How does that line move throughout your piece? How much space does it take up? Is it taking up a lot of space or a little space? Where is it placed in the frame? Those are all considerations of form. So here I have the volume occupied by an element, and I think that's really driving home exactly what form is. How much space is it taking up, and how is that space distributed throughout the piece? So now we get to add those things into a broader set of values or ways of thinking about art. These are the principles of composition. So remembering that everything on this slide is making up a piece that can have all of these elements and does have all of these elements. Every piece of art has all of these elements, and it's a matter of being able to discuss them in detail. So using these things as lenses is incredibly important to understanding and comparing and reflecting on your art. The first thing I've got here is rhythm. So rhythm is just like a musical rhythm. What's the flow of the piece when your eye moves across the canvas or across the digital artwork? Is it consistent? Does it feel jagged? Do you feel like you're moving from one side to another? How does your eye move? So this is a very feelings-y sort of lens for discussing art, but it seems to be universal. So a lot of people get the same sense of rhythm out of different pieces, but it comes down to seeing a lot of art and reflecting on the ways that you interpret that rhythm. So I'll give you a couple of examples and some slides, don't worry. these three definitely go very well together, which is why I've paired them so. Balance, symmetry, and emphasis. So balance can create a sense of symmetry, and it can also create a sense of emphasis. Of course, we all know from elementary school art class that symmetry is when something is the same on either side. You can have radial symmetry, which is where things are symmetrical, spiraling out from the center in pie slices. So that work of art that we looked at last time that was grayscale with the sounds of all of the planets in their solar system would be utilizing symmetry to draw attention to the differences between those pieces of data, for example. Balance is more referring to the way that a scene feels, and specifically, usually it has something to do with the rule of thirds. So the rule of thirds is the number 1.6. It's very deeply embedded into art theory, especially Western art theory. So once you start noticing it, you can't unnotice it. And this sense of balance typically centers around that 2/3 rule. So we'll talk about this again in detail, but typically a very well-balanced work of art will have 2/3 of the canvas dedicated to one sort of section, and then 1/3 of the canvas balanced with such a section. Emphasis is typically the ways that balance and symmetry are kind of upended, or those rules are broken in some way. That draws a lot of emphasis to a specific piece. In addition, something can be emphasized with color rather than form. Therefore, an artist might need to be thinking about balancing with form or pattern, utilizing their rule of thirds. So rule of thirds, again, is just a way of conceptualizing a piece of art. Gradation refers to the flow of a piece. Are the changes gradual or immediate? This could definitely refer to color, which is what I have an example for you here. However, it can also refer to the use of pattern or the use of form. So are you seeing something really smooth to really rough? Are you seeing something that is really bright to really dark? Or are you seeing more of a gradual, slow fade? Something that's misty would be quite gradated. That's how you would perceive it as such. Harmony and variety. I have an example of 2 patterns or textures here, and this is really looking at the ways that these things are the same or different. Are they discordant or concordant? So that brings us back to what I was talking about on our last slide. How are things getting along? That also has to do with our color rules from our last class. So are these things falling into neat, beautiful color boxes? Or are they inhabiting opposite spaces on the color wheel? Perhaps they feel clashy, and sometimes that clashing can be utilized to create a sense of disharmony in a piece. Movement throughout a piece does not necessarily refer to actual movement. Today, we're going to utilize actual movement to hold the eye and move it around the canvas, but movement can be a sense of movement. So I include here this beautiful little icon of a wizard's hat. I think it has great movement in it. So you can kind of see that based on your preconceived notions of these forms and based on the way they are situated in this tiny little frame, they appear to be moving in some way. At least that's my interpretation of this icon. Last on this frame, we've got proportion and scale, and I intentionally utilized those same colors and box forms, and they are still within that same scale, just scaled down, to show you how different something might look based on the proportion and the scale. So this can also have to do with gradation, or it can have to do with harmony and variety or rhythm. All of these things are leaning on each other. But proportion and scale, I think, is very self-evident in language, sort of like how patterns are. Are you seeing a lot of variety in the forms in the piece? Are you seeing big and small? Stuff like that. So why in the heck does this matter? I think there can be a tendency to write off art theory, especially rhetoric like this, as being gatekeepy or being jargony, and I also tend to dislike jargon, but these things are really important and words are really important because they give you the ability to put on a lens. So now I hope when you look at a piece of art, you're able to see all of these elements of composition inside of the way you are actually perceiving it. So instead of saying, I like this piece, I don't like this piece, it looks good, it doesn't look good, you can actually self-reflect and reflect out to other people on this common ground. I like this piece because it has a lot of balance and symmetry. I don't like this piece because I don't like how disruptive the rhythm is, and things like that. So this guy, Frantz Fanon, is a philosopher and a psychiatrist who moved around to a lot of different cultures. And he said to speak a language is to take on a world, a culture. So we're learning the language of art, and we're learning the language of art in order to be able to reflect on ourselves and our relationship to this culture of art. Now we're going to take a look at a few famous pieces of art and then a few pieces of generative digital art utilizing this frame. So we're going to do a little bit of practice. I'm going to talk to you about why I picked these pieces, why I think they're important. But while we sit here and I'm jabbering at you, take a look at this piece and just reflect. What is it that you think is important about it? Why do you think I've put it in here? Thinking back again to rhythm, balance, and symmetry, and emphasis, gradation, harmony, variety, movement, proportion, and scale. So while we're taking in this piece, this is Caravaggio. It's the Crucifixion of St. Peter. It was painted in 1601. There's a lot of religious imagery in art at this time period, especially in this part of the world. And this specific piece is telling this really detailed religious and symbolic story, utilizing color and light and contrast. So I think that's the biggest thing that pops out at me about this piece specifically, is the huge depth, the huge range in tone, and the huge range in brightness of the piece. Of course, there's a huge lack of balance in this piece. Everything is sort of leaning to the right-hand side. It's got a huge pull to one side of the painting, and that gives you a sense that things are not going great. You know, there's a lot of conflict in this piece, and not only does that have to do with the actual character of St. Peter inside of the piece, but it also has to do with the way that this is framed. I really like the deep, dark, brown, red backdrop of the right-hand side of the painting. I think it gives the sense that they are walking into nowhere or walking into this deep, dark cove almost. So the lack of balance, like I said, is really about discomfort, and the color scheme itself contributes to that balance in addition to the forms in the piece. Here we have something completely different. So Pierre Mondrian is a abstract painter. This was painted in 1942 and 1943. It's called the Broadway Boogie Woogie, and it is one of his most famous pieces. So he's the guy with the squares, if you're looking to remember your art people. But here, I think color and pattern figure really heavily in the way I perceive the piece. So there's huge contrast. Everything is super saturated. Saturation to me feels very energetic and not busy, but just like it brings a lot of energy to the piece. The repeating patterns are regular, but unbalanced. So you see like the left-hand side here has 3 lines, whereas the right-hand side has 4. There's little breaks inside of the symmetry of this piece, which again contributes to a sense of motion. Whereas we have these beautiful little repeating patterns that are kind of squished together in some places and far apart in other places. This looks a lot like flocking behavior in human beings and animals, which I think is a great use of pattern and a break from pattern to create a sense of motion and of representation in this beautiful little abstract piece of art. And by little, I don't mean little. Mondrian's canvases are quite big. You should look them up. Next, we have one of my personal favorite artists, Frida Kahlo, and she is a surrealist painter from the kind of the same time period as Mondrian, just a little before. This painting was painted in 1932, and this is when she was laying sick, kind of towards the end of her life. So here she's utilizing scale to draw emphasis to things that maybe wouldn't typically be this large or figure this this importantly inside of a piece if they were at scale. So she's utilizing surrealist scale to tell a story of the piece. I also really like these buildings back in the background. She gives a huge sense of setting, but there's this really, really empty space and these long shadows that don't exactly correlate to everything on the horizon. And there's something really strange and unsettling about the selective use of light, the non-natural use of light in this piece. And I think it's a really important part of her work. So she's utilizing things that would traditionally be used to make something look real, but she's utilizing them in ways that sort of bend reality. Now we're going to turn our view just briefly to a couple of generative art pieces that I think drive home at the same concept. This one is a little challenging for me personally to look at on a screen. I think these lines are a little close together, but there is something really cool about the way that it plays with your eye. That sense of perfection is something that you find a lot in modernist painters around the same time as Mondrian was painting. But the digital space just gives you an absolute sharp sense of perfection that is almost impossible to achieve on a canvas. So this use of repeating lines creates a rhythm, but the rhythm becomes irregular with those other lines breaking it up. So we've got lines that are spaced exactly the same, but they're creating forms by using this trick in your brain that things that look the same tend to be associated as a part of a figure. So this is utilizing continuity, which is a Gestalt principle, to create forms inside of this repeating pattern. I also love the balance here in this piece. It's definitely utilizing rule of thirds. So we're leaning heavily towards this part of the painting, but things are quite balanced because we have these shapes here that kind of balance out here, and these shapes here, which balance here. So there's a lot of balance inside of this piece, even though there's that huge contrast in these very simple patterns. Next, we've got this beautiful piece of motion graphic art. So this guy, Patrick K. Hubner, is utilizing these repeating shapes, utilizing a pattern, and creating contrast inside of that pattern to give this optical illusion of movement throughout the piece. So just remember, these are just ovals rotating, but because of the way your eye perceives this art piece, there's this beautiful sense of true rhythm in the piece and a sense of form because of the contrast between those two pieces, or between those rotating circles. So here we are, we're about halfway through our lecture right now. And we are going to talk briefly about recursion, and then we're going to get into our demos. But before we do that, I have a little mini demo for you. I think we're going to break this up a bit, and we're going to look into moving patterns and just like sort of the basics of movement in P5.js. So meet me over at your P5 editor. So again, that's editor.p5js.org. And we're going to create a little work of motion graphic here. First, I am going to leave my background here for now, but I'm going to change it all the way to white, and you'll see why we're doing that in a bit. The next thing we are going to do is create a grid of squares. So in order to create a grid of squares, we're going to utilize a loop function inside of JavaScript. This is a common form of code, and it's really useful in generative art for creating repeating elements. So loops are something that repeat until they meet a stopping condition. They're slightly different than recursive code, and we'll get into why in a few moments. But right now, we're just going to create a single square because I'm going to talk you through a new way of moving squares around the canvas. So let's just do a square at 0, 0, with a size of size. So I'm going to initialize a variable to control the size of our squares so that later on in this exploration, we can jimmy with that and change it and see what we think of it. Also, because this is just going to be a plain white line on a plain, or a plain black line on a plain white canvas, I'm going to give it just a little bit more thickness in that stroke. So to do that, we're going to utilize the stroke weight command. And let's see what we end up with here. So just a square at 0, 0 of size 50. Very easy, very self-explanatory. Now we are going to translate this square. Stick with me because this is a very important part of using the loop to move things around the canvas. So there's a reason why we're doing this. And let's do width divided by 2 for our x condition and height divided by 2 for our y condition. Now we've moved our square to 200 pixels in and 200 pixels down. But I'm going to draw your attention to the fact that this square is actually outside of the center of my canvas. The reason that's happening is that we are utilizing a rectangle mode inside of P5.js that does not account for the center of the square. So just for peace of mind, and because I think it makes this specific exercise easier, we're going to do rect mode and we're going to say center. Now this is all in capital letters. Anytime in P5.js you're passing some sort of condition into a P5 function, a built-in, you want to make sure that everything is in all caps. That's a pretty standard P5 procedure. Okay, so we've got our square, we've got our translate. The last thing we're going to learn how to do is actually rotate things inside of P5. And wow, rotate. We're going to rotate this by the frame count. So what's happening here is that P5.js is running at 60 frames per second, and it's rotating our square by that amount utilizing radians. So P5.js is always working in radian mode until you change it. We're going to slow it down a little bit by using angle mode and changing it to degrees. And you'll see a change right away. It's going to slow down that square. So now we're doing out of 365, 60 frames per second. So we're going around this loop much, much, much slower as opposed to doing it in radians, which is 2 pi. So we were basically going around the loop like twice or once every 2 seconds and change, 3 seconds and change. Hopefully that's right. Hopefully I didn't just embarrass myself with math. Okay, so now we've got our square, we've got it translated to width 2 and height 2, and then we're going to rotate that square. Just briefly, let's see what happens if we move this rotate command to above the translate. All right, so now you see that we are actually rotating around the point 0, 0. That's because we did the rotation before we did the translation. So if you ever feel like you're getting an effect you don't want to with the translate and rotate, just try flipping them around and usually that'll solve your problem. So just for today, the effect we're going for happens to be one where everybody rotates in their place. So we're going to move this back to where it goes in this piece. All right. So the next thing we're going to do is create our loop. First, we want things to move across, and then we want things to move down. So essentially in a loop, we're going to make a line of squares, and then we're going to take that line and pick it up and move it down our canvas and make copies of it. So our first loop we need to build is the one that puts our squares horizontally across our canvas. We're going to do for. This is just the way a for loop is structured. And then typically the first alphanumeric character that you put inside of a loop is I. So we're going to follow convention on that. I want my squares, excuse me, I just forgot the name of that shape, to be spread across our canvas by a fixed amount. So I'm going to initialize a variable called spread, and then I'm going to set our spread to 100. Obviously, right now, nothing has happened, and what is actually happening here is we're drawing all of our squares inside of this single location, so we need to make sure that our translate command makes its way inside of our function. Just a reminder that of course you want your rotate to stick with your translate if you want things to rotate in place. And now we are going to translate our squares. See, this is kind of the amazing thing about art is you can move things around and explore with them and see how they end up. Right now, we are going to change our translate so that we're translating by I each time. I is going up by the amount that we want our squares spread apart. So now we've got our squares spread apart by 100. And we've got squares that are size 50. But you'll notice here that we are still kind of like randomly rotating our squares around an axis. They're all rotating around 0, 0 right now. And that's because every time we run this loop, we're adding to the rotate and translate. So what we are actually going to do is utilize this command push and this command pop. Now push and pop make it so that we are returning back to 0. We are resetting each time we run this loop. So now instead of translating by I and adding that each time and rotating by frame count and adding that each time, we are moving each of our squares by I and then we are rotating them all by frame count. So we need to, again, like I said before, take this work that we've already done, our line of rotating squares, and we want to just pick it up and copy it down. So the way that I would go for that is to create another for loop. I'm going to add a tab to this just so it's a little farther out. And then traditionally your for loop is going to be J. And then this is going to be height because we're doing our Y direction. We're going to add the same amount of spread because they're squares, and utilizing our art composition principles, I want everybody to be equally spaced and equally sized. So we're going to utilize the same spread that we did for our other side of the grid. And then I'm going to add spread each time we run our loop. So right now we are telling this to run from the number 0. We're going to add the spread to J, and then we're going to stop as soon as J is the height and the width plus the spread. The reason I added spread to the height is so that we're going off of the canvas. If I was going to go just to the height and the width, we would cut off just a little bit before the edge. All right, so the last thing we need to do here to create our squares that move across the canvas is just to translate by J each time we loop as well. Just a reminder, if I removed that push and pop command, things would go completely haywire, and that's because I'd be adding to each movement with the next movement. So translate is an additive command, and we need to make sure that we are starting from 0 and then adding in that I and J each and every time. So just to make sure I'm driving home this concept of the push and pop and why we're utilizing it inside of this space, I'm going to show you how I would create a grid if I was going to use translate without utilizing this push and pop command. So you'll remember what we're doing with push and pop is basically resetting translate to 0 each and every time we run this loop. If for some reason I wanted to create a grid and not utilize push and pop, which would not work if I wanted to rotate utilizing frame count, I'll drive that home for you. So that's why we're using it in this specific situation, but it's very possible to create a grid utilizing just loops without push pop. So I used my control and then backslash button or command if you're on a Mac just to comment out my code. Now I'm going to create a very similar for loop. And I'll even do the same counters. For this first one, I am going to translate by spread each time and then by 0. So this is going to create a row of squares just like what we had moving across the top of the screen, and that's because we're adding spread each and every time we run this loop. So let me create for you a couple of squares. And then now we see the squares running along the right-hand side of my screen. Of course, we are translating by spread before we draw the square, so if I was going to be true to form, I would want to translate after I draw. So I'm draw, move inside of this loop. Now we've got a very similar effect to the one we had before. Last but not least, we would want to create our nested loop utilizing J. Now, here's where things get a little bit trickier. You have to use your brain in kind of a different way. We are going to translate our squares in the Y direction by spread, technically after each and every loop. Oop, what's going on here? Unexpected token. Let me just do a quick little, oh, we're missing that. All right, cool. So now you see here that I am translating by spread and then moving down the canvas. Let's try moving our spread to the bottom. Oh, I see what's going on. So here we are resetting to 0 each and every time we translate in that direction. The easiest way to get around this would be to create a counter variable for X and Y and utilize that on each loop. So instead of doing just spread, I'd be actually adding to the counter every time. Now you're kind of seeing why we're utilizing that push and pop. It's kind of just an efficient way to go about moving through the grid space. I strongly recommend that you use that inside of your loops. I think it's super efficient. So if you're looking for a little bit of an extra challenge, take this to where it needs to go to create a grid. I need one more thing, which is a specific variable for X and Y that is increasing each and every time. Great. Okay, let's return to our loop. The last thing we're going to do is just add a little bit of color to this piece. Right now, it's kind of bland. It's really cool. I love the black and white. That has its own merits. But I think what's really cool about doing some color, additive color inside of our draw function is that you can see the way that the frame count is increasing throughout the piece. So I'm just going to do S_col, which is the color of my stroke. And then we'll initialize that variable in setup. Last, we are going to make our stroke. I'm going to use the color red and then just as dark as possible. So no green, no blue. Right now, everything is at 0. So I want to increase my stroke color each and every time we loop. So those 2 plus signs is just me telling the sketch every time you go through a loop, every time you get to a new frame, add 1 to S color. So if I restart this a couple times, you can see my S color increasing with the frame rate. That also gives you a really great built-in sense of how fast that's going. Cool. So we've learned a little bit about doing some basic animation and bringing some of the things we learned about art composition inside of our frame using repeating functions. So here we're using for loops to create a grid, and then we're rotating that grid, which I think is so cool. And then we're changing the color of these objects. Cool. So returning to our lecture, let's talk just super briefly about recursion, why recursion is important, and then I'll show you how to utilize recursion inside of a generative art piece. I put here that it's the special sauce of generative art. I truly believe that. Just about anything I see where I think, wow, that's really remarkable, I am totally taken by that piece. It's utilizing some kind of looping or recursion, but 9 times out of 10, it's something recursive because recursion is just a really cool mathematical concept. So what is recursion? Again, it's math. It's a mathematical concept where a series is defined in terms of itself or a number similar to itself. The classic example of this is the Fibonacci sequence, but n equals n minus 1 is a perfectly valid example. So we're referencing n inside of our function, but we're referencing it in a changed way. One thing of note about recursion in computer programming, this is infinite, n equals n minus 1, and you never want to create an infinite loop inside of your code. So you always want to make sure your recursion has a stopping condition or something that slows it. So the recursion that we are going to explore today is time dependent. That's our slowing condition or our stopping condition. You can't have an infinite loop if you're always changing by frame rate. So this is an example of the Fibonacci sequence. Basically the same thing as the golden mean, which we talked about earlier. It's another way of mathematically representing this number, the golden mean. And it's very common inside of Renaissance art because it was just kind of a part of the public consciousness at that time. And you see it represented here. So basically what you're doing is you're taking the number before the number, and then you're taking that number before that number, and then you're adding those two numbers together. So 1 and 1 is 2, and then 2 and 1 is 3, and so on and so on and so forth. So definitely go look up Fibonacci if you're interested. It's just the classic example of recursion. Recursion, I think for most people who have computer programming experience, is associated with solving a specific subset of problems. The problem that you typically see in a computer science class solved with recursion is the Tower of Hanoi, and you're seeing that played out here. So the problem is essentially there are 3 pegs. There is a stack of disks. I want to move the disks from one peg to another without putting a disk that is larger on top of a disk that is smaller. And you utilize that recursive function to move these disks around in a repeating pattern to free the base, and then, as you're seeing here, sort of move everything back into the order it is meant to be. We're not going to get into the solution of this problem today. I think that it's totally worth looking into if you want to spend that time. We just are time limited right now. So just go YouTube it, go Google it. What is the solution to Tower of Hanoi in JavaScript specifically, if that's what you're interested in and you've never been exposed to this problem? It's definitely worth looking into. In terms of art, recursion is a pattern and movement that's creating a rhythm inside of your art piece. So this is a beautiful little piece of recursion. We're basically infinitely falling into the Simpsons hole here. So we are going to aim for something that's kind of like this inside of our recursive pieces. So let's do it. Let's go generate some recursive motion. Right now we are working with this sketch. I recommend you save it. We're going to open a brand new fresh one to get to work on our recursion. So again, basically what we're going for is something that looks exactly like this Simpsons piece. If you ever see something like this, it's recursion. Straight up, that's the only way that you can create something that looks like this, where you're infinitely falling into a repeating pattern forever. So we're not going to do that. We're going to do something much more simple than that, but it's going to teach you the principles of creating a recursive function so that you can explore that in the future. You're going to be so surprised at how simple this is. It's the coolest thing. Like, it is magic to me. So we are going to create a function. This function does one thing and one thing only, and that is draw a circle. This circle has a couple of conditions. We need to know the x position, the y position, the radius, and then we need to know the stroke weight. In fact, we'll come back to stroke weight. All we need to know is the x position, the y position, and the radius. Cool? We are initializing our canvas. We have a background. We have our canvas drawn, and now we're creating a draw circle function. So just the same as our draw and setup functions, we open our function with these brackets, and then inside of our function, we are going to give our circle a stroke. I'm going to make our stroke 255, so white, which also means to add some contrast to the piece, I'm going to make this just a little darker. The next thing I'm going to do is add no fill. No fill will just make all of our shapes empty. We're going to focus just on the stroke today. Next, we are going to we're going to use the ellipse command, get a little wild, utilizing X, Y, R, and R. So ellipse is basically the same as a circle, only it can be wide and tall. We are just going to create an ellipse that is the same width as height. But if you wanted to take this function into an ellipse direction, you could do that too. So we're setting it up in a much more broad way. Okay, now we can use our function to call the function inside of itself. I suppose before we do that, we should just test to make sure it works, right? So let's go ahead and draw ourselves a circle. Remember, we are doing and then I am going to create a variable called radius so that I can change it outside of this function call, which is best practice for later. We'll initialize our radius at the value we want it to be, let's say 10, and then let's see what we get here. Beautiful. We have a circle drawn in the center of our canvas that is a radius of 10. It's exactly what we're looking for. So the next thing we're going to do is actually call in some recursion into our function. You will remember that we need to have a stopping condition. And that is true here as well, because we want to make sure that we don't overload our computer inside of this recursive beautiful space. So our stopping condition is going to be, we never want a circle to be drawn if its radius is greater than 40. So basically what we're going to do is we're going to take our radius, we're going to increase its size, and then we want to make sure that our radius never gets any bigger than 40. So if that's true, if our radius is, oh, yikes, I'm backwards. If our radius is less than 40, we are going to draw a circle. And we're going to draw our circle at x plus r, y, r times 2. And basically what we're going to see here, is our circle moving outward and then getting larger. So I hope this is tracking for you. Basically, we're not drawing our circles bigger than 40, so this is smaller than 40 radius. And then each time we draw our circle, we're going to move out by radius and we're going to increase the radius. So that's how we approach our stopping condition. I think I'd like to make this just like bigger so we can go farther. Next, I think that because we're looking for something that has a beautiful and balanced composition, we should repeat the same process in all 4 cardinal directions. So let's draw a circle at x minus r, y, and then r times 2. So we'll see the same thing. Wow, that's so cool, on both sides of our screen. And then I was going to draw vertically as well. If you were to do that, you would just go ahead and do the same thing except for in the y condition. So we'd keep x fixed, we would add r, and then we'd multiply our r by 2. So you'll see that I'm moving into the y direction. However, I think this is getting a little busy. So we're going to keep it simple and we're going to move only in the x direction. And in the interest of keeping it even more simple, I'm going to max out our circles at a little bit smaller size and maybe spread them out a bit more. So we'll do like 2 times r instead. Yeah, that looks great. Okay, so cool. So the thing we need to do to add some sort of animation to our piece is we need to change our radius size utilizing the frame count. So let's explore a radius that is, I don't know, let's do like, something like this. Cool. Okay, it goes a little fast, so let's slow it down a bit just so we can all like process what's going on here. Cool. I think that's super cool. The only thing that I don't like about this is the way that we get sucked into the center circle, just like you would see in that Simpsons piece. And then now it's kind of gone, which is a shame. So we could improve that by potentially increasing the size, so that'll make it take a little bit longer. We could improve that by making it even slower. I'm going to propose, however, that we improve that by utilizing sine and cosine. So I'm going to use sine. You'll remember from your old school math class that sine is a number that varies between 1 and -1, as is cosine. So basically it's a wave. And we're using this wave function to go close and far and close and far, or at least to simulate the experience of close and far and close and far. So I think it's going a bit fast for us. The best way to do that is the same way we solved this problem before, which is changing the angle mode to degrees. So now we're moving at a rate that is going around the 360 angle rather than looking at the rate that is 2 pi. So we're going much slower now. So now you can see we kind of like go big, and then we should reach a peak and then come back down. You'll just have to trust me. It's taking my computer a while. It's starting to get tired. Hopefully you see the same thing on your screen. Okay, so this is a great way to explore recursion. I might take this even farther on my own time. You could also go ahead and flip-flop this. That's another great way to add some tweaking. So instead of doing less than, we're going to do greater than. We're going to subtract r, and then we are going to divide r by 2. So instead of our stopping condition being related to how big things get, we're going to make our stopping condition related to how small things get. And then of course, because we've got a radius of 10, I'm going to start us up a little bigger, not 600, holy cow, 60. And then I'm going to make our minimum or our maximum radius closer to, let's say, 100. So now we see a totally different effect, but still recursion. So we're seeing things zooming in, getting bigger, and then now, because we're using the sine function, we're going to eventually zoom out on our screen. Just for the sake of time, let me speed this up for you just a bit so we can all see the full effect. Cool. So it goes up and then it goes back, and I can tweak all of these numbers. So I could do like 400 just to see a different effect out of this. I hope that makes sense for you. I hope you understand how recursion sort of works. Again, sort of with the spinning squares, you could take this and go incredibly far with it. So it's all a matter of just exploring kind of what you feel called to explore and doing some art. So just doing some play and seeing kind of what comes out of it. So again, I'm at office hours if you need anything from me. I'd love to help you with your code. But this is just a basic overview of the ways that you can start playing around and creating some really cool recursive and generative art pieces that I think are fun to play around with and super, super cool. So yeah, thanks for joining me for class 2 of art and code. And next week, we're going to jump even deeper into utilizing this like breathing sine motion for creating natural motion. And then, like I said before, we're going to look into Perlin noise, which is a type of noise. So it's randomness, but it's a type of randomness that is meant to be more natural. So we'll explore that inside of this motion graphics space.